This so late. Hopefully you still have time to watch it before tomorrow. Tonight we are talking about multiplying fractions. So this week we've added and subtracted fractions, we've worked on simplifying them, and now we're going to multiply these fractions. So let's review a couple things that we've talked about so far. So our fraction, remember, is made up of two parts. We'll see those in just a minute. It's our numerator and denominator, and we can write it as part over the whole. So this is the whole piece that I have. So if it's a pizza that I'm talking about, that's my whole pizza. Part is each slice, or how many slices that I have. The numerator, remember, is the top number. We call that the part. The denominator is the bottom number. We call that the whole. And if we were to write this with a numerator and denominator, our numerator's on top, we represent that with an N. Our denominator's on the bottom, we usually write that as a D. Okay, a couple other words you're going to need to know for this assignment is the word of. We've all heard this word before. In math, it's an important word. Of means to multiply. One of the many ways we say to multiply or to times. So what that means is if I said 2/3 of 5, you would multiply 2/3 by the 5, and it would give you what 2/3 of 5 is. Okay, some of the different ways that you're going to see multiply written. We have our X, our cross for our multiply. Sometimes we have a dot for a multiply. On this one you might even see a little star for a multiply, or parentheses. These are all different ways that I can say multiply. But if you're reading it in a sentence or a story, you're looking for that word of. Okay, the last vocabulary word I want you to know for tonight is cross, simplify, or cancel. And this is just a shortcut to simplifying our fractions. So we learned how to do that yesterday. Today we're going to see a little bit of a shortcut when we're multiplying. Okay, a little bit of background before we keep going. Something you need to know is the commutative property of multiplication. A property in math is like a rule. These were made up by mathematicians a long time ago that studied these things. They tried it a bunch of times to make sure it always works, and they wrote properties. The commutative property, so when you're doing multiplication, it tells us that it doesn't matter what order the numbers are in. So if I look at 2 times 3 right here, hopefully all of you know that that's going to equal 6. Okay, if I reverse the order and do 3 times 2 instead, does that change anything? No. With multiplication, order doesn't matter, and I will still get a 6. Okay, before we're ready to multiply fractions, let's go through the steps. Step 1, we want to cross, simplify, or cancel wherever we can. We'll see what that looks like in just a minute. Step 2, we want to multiply straight across. And finally, we want to check that our answer is simplified, like we were doing yesterday. Okay, and also I want you to remember that any number over itself equals 1. So if I have 2 over 2, or 2 divided by 2, it equals 1. This will happen for any number. So 100 over 100, it equals 1. It doesn't matter what the numbers are as long as they're the same. This pow-pow we'll talk about in just a second. Go ahead and come up here to the first example. Okay, the first step was to cross, simplify, or cancel wherever we can. Okay, this is a little bit different than addition. When we're doing our multiplication, we can use the fractions just as they are, but to help with simplifying, it's going to help if we cancel some things first. So looking at this, we call it cross, simplify. I'm going to look at my diagonals here. I'm going to start by looking at my 3's. 3 and 3 are the same. I can cancel them out, meaning I would end up with a 3 on top and a 3 on the bottom. So they're both going to reduce to a 1. So they don't go away entirely. There's always a 1 left there because 3 divided by 3 is 1. Okay, my 2 and my 4 aren't the same. We'll see in a minute how we can still reduce those, but for now, I want to just leave those how they are. Okay. Now that I have cross simplified, I'm going to multiply straight across. I like to draw little arrows to represent this. Okay, I got rid of my 3, remember? It turned into a 1. 2 times 1 is 2. 1 times 4 gives me 4. This is where the pow comes into play. When you multiply straight across, you can finish it and say pow. On the bottom, finish, pow. Pow, we're done. Nothing too complicated there. Okay, but now I want to look at my 2/4. Is this simplified all the way? Hopefully you're shaking your head no. Okay, 2/4, maybe you've seen it already, is going to reduce to 1/2. If I'm not sure, I can write out the factors. I've got a 2 on top. I've got a 2 times 2 on the bottom. I see that this 2 on top and this one on the bottom are going to reduce and give me a 1, so I'm left with a 1 on top. I still have 1, 2 left on the bottom, and this simplifies to 1/2. Now I'm done. Okay, let's look at our next example. Okay, you can see they're using the star here to represent our times. That's what we're still doing. Let's look at our diagonals. Okay, 7 and 14 aren't the same. 3 and 12 aren't the same, but do you see that they have common factors? We know that 7 goes into 14 2 times, so I can divide both of these pieces by a 7. When I divide 7 by 7, I'm left with a 1. When I divide 14 by 7, I'm left with a 2. Okay, let's look at our other diagonal. Is 3 a factor of 12? It is. I know that I can divide 3 by 3 and then get a 1, and when I divide 12 by a 3, I'm left with a 4. So now I'm going to rewrite this down here just because it looks a little messy. I have 1/4 as my simplified fraction times 3 over, that's a 1 now, 1 over 2. Okay, because I simplified across the diagonals. So 7/12 doesn't simplify to 1/4, but because I'm timesing, I'm allowed to do this. Okay, again, I'm going to do my pow. I'm going to multiply straight across. 1 times 1 equals 1. 4 times 2 equals 8. I have a 1 on top, so I know that this is in its simplest form. Going back to those rules on our cheat sheet from yesterday, I know that I'm done. I can't make 1 any smaller, so I'm left with 8 on the bottom. Okay, let's go through a few more examples. I know this takes some practice, especially the cross-reducing or cross-simplifying. Okay, looking at number 1 right here, maybe I'll zoom in just a little bit if it'll let me. Okay, that's a little bit bigger. Okay, looking at this, I'm going to draw my X in the middle, my cross. Okay, so I'm looking at my 4 and my 4. Those have a common factor. It's 4. It's itself. So when I divide both of these by 4, I'm left with a 1 in their place. What about 3 and 9? Yeah, 3 is a factor of 9, so I can reduce these as well. They're both going to be divided by 3. That divides by a 3, it turns into a 1. That divides by a 3, it turns into a 3. So now I have 1/3 right here times 1 over 1, which is just 1. If I rewrite that so I can see it a little bit better, this is what it looks like when I multiply straight across. Pow, I get 1 over 3. That's as small as that can go. They're both prime, and I also have a 1 on top. That is my simplified fraction. Okay, let's look at number 2. They've got our X here to represent our times, but it also works nice for our crossing. Okay, looking at this, 3 and 12. Those can be reduced. I know that 3 goes into 3, giving me a 1. 12 can be divided by 3, giving me a 4. What about 8 and 11? I know that 11's prime, so I can't reduce this at all. Those are going to stay the same. When I multiply across, I get 1 times 11, which is 11 on top. I get 8 times my 4, which gives me 32. If you're not sure, look at your multiplication table. And I get this. Okay, I went ahead and put my box around this. First, I would want to check, though, if this is simplified. Does 11 go into 32? No. 11 goes into 33, but not 32. So I know I can't reduce that at all. The reason I'm looking to see if 11 goes into it is because I know 11's prime. So that's why I'm checking. If they had a common factor, I could also simplify that. I just know that 11 didn't have any other factors. Okay, number 3, they're using the star. It still means times. We've got 4 different ways that we're showing times on these. Okay, these fractions are already simplified. I'm going to look at my diagonals. They're both reducing with, or they're both across from a 1, so that doesn't really help me. This is as simplified as I can start out with. Okay, I'm multiplying across the top. I get 1 times 1 is 1. On the bottom, I have 5 times 3, which is 15. Okay, I have a 1 on top, so I know this is in its simplest form. Go ahead and put a box around that answer. Okay, last one before I sign off. Okay, parentheses with a number in front means to times. So I'm still going to do my cross right here. Okay, 5 and 10, they'll share a common factor. It happens to be 5. So 5 goes into 10 2 times, so that one's going to be a 2. 5 goes into itself once, so that's going to be a 1. 3 does not go into 8, and they don't share any common factors, so those are going to be left alone. If you like to rewrite it, you can rewrite it. If you can just see it, you don't have to do this part. I have 1/8 times 3 halves. When I multiply straight across, I get a 3 on top. 8 times 2 is 16. Okay, now some of you are going to look at this because you've got a 3 and a 6, and you're going to try and simplify that. But guess what? We're looking at this whole number right here. Does 3 go into 16? No. It looks tempting, but 3 goes into 15 or 18. 3 does not multiply ever to equal 16. So, and 3 is prime. I don't have any other factors. That's as simplified as it can go. I'm leaving this guy just like this. Okay. You've got a few more to try on your own for the pause and try. Go ahead and stop the video, work these out, and I'll see you tomorrow in class. Bye!